This is an operating systems question based upon memory allocation for a process. We are having a new process to which memory has to be allocated, assuming that none of the existing holes in the memory will exactly fit the process memory requirement, which means if you are having a process of size, let us say 40 KB, then there is no hole of exactly this size. There might be smaller holes and the larger holes. So a new hole of smaller size will be created if allocation is made in any of the existing holes. So now if we have to accommodate this process, we are not going with paging or anything. We have to fit this process in one of the existing holes in just one single piece, which means we will need a hole that is larger than 40 KB for this purpose. And when we will do that, let us say you pick up a hole of size 75 KB, then you will insert this process of size 40 KB in that, and then the new hole will be left out, which will have a size of 35 KB. So this existing hole, we accommodate a process into it, and then the new hole that got created has a lower size of 35 KB. So this is how this allocation has to be made. And they're asking which of the following statement is true. And in these statements, as you can see, they are talking about the policies that we have for performing such an allocation. We have the first fit, worst fit, best fit, and the next fit. These four have been discussed over here. So let us take an example and analyze for all the four cases whether the size of hole created by which one is the least and which one is maximum. On that basis, the statements have been formed. So let's analyze. Let us consider the process of size 40 KB itself. And then these three options we are having, let us call them 1, 2, and 3. And for all these three cases, we will be using these different policies: first fit, best fit, and the worst fit. And we will analyze the size of the smaller holes getting created. So first of all, let us also understand the difference between all the four. There is also this next fit. Coming to the first fit first, as we know, let us say these are our memory blocks and we are having pointer at the beginning of them. Then we want a hole that has size at least 40. So we will start traversing from the left, and the first hole that we will encounter having the appropriate size, we will be using that. So this is what refers to the first fit method. And what is the difference between first fit and the next fit? There is a little difference that in the next fit, what we do is, let us say if our previous hole was allocated in this particular location. So now in the next iteration, we will start searching from the next one and not from the beginning. So it saves us some of the time. For example, this is our memory. You are having two processes, and the first process got a hole accommodated at this particular place. So now while searching for the next time, you will not start searching from the beginning, but you will start from this particular point onwards. So that is what called as a next fit. It is the only difference. But in our case, we can safely assume that the pointer is starting at the beginning of the memory block itself, so that this first fit and next fit will give the same result. And then next, coming to the best fit, what does it do is it will traverse the entire memory block and it will find out a hole that is having size just greater than 40, which means it will make sure that we create the smallest possible hole so that not much of the memory gets wasted. And at the last, coming to worst fit, what does it do is it will also traverse the entire memory block and it will search for the largest possible block for accommodating this. For example, if you find a block having size 1000 KB, which is the largest available hole in that block, so this particular hole will be used for accommodating this process. Why does it do so? So that the size of the hole that is created is large enough to also accommodate some other process in the future. And what does best fit assume? That the smallest possible hole should be created and it will go waste. It does not consider whether or not that hole must be usable in the future or not. So these are the four allocation techniques that we are aware of. So let us analyze for our process having size 40 KB. So in this first case, when we use the first fit, then the hole which we will be using is this, having the size 80. So the hole that will be created will have the size of 80 minus 40 equal to 40. Similarly, if you use the best fit in this one, then the hole that will be used will be this 50, having the size 50. Hence, the hole created will be having a size of 10. Similarly, coming to worst fit, it will use this 100, and hence the size of the hole that will be created is 100 minus 40 equal to 60. And what about next fit? It will give the same result as first fit itself, because we are considering the pointer to be starting at the first location itself. So now coming to the second example, when we apply first fit into this, the 50 sized hole will be used because that is what we encountered first. Hence the hole will be 10. Then coming to best fit, it will also use this 50 itself because that is the smallest possible hole. So here also hole size is 10. Coming to worst, it will use 100. So hole is 60. Now coming to the third case, when we use first fit, it will use 100. Whichever it encounters first, that is blindly used. So here the hole will be 60. For best it will be 10. For worst will also use 100 itself. So for that also the hole will be 60. Now as you can see, the best fit and the worst fit are not concerned with what are the order in which the holes are placed. The best will always choose the smallest possible hole, worst will always choose the largest possible hole, and hence you can see the hole size is same across all the cases in them, 10 10 10 and 60 60 60 respectively. But when it comes to first fit and the next fit, the size of the hole is variable depending upon which one was encountered first. So now let us have a look at the options. The hole created by first fit is always larger than the hole created by next fit. Now as we saw in our case, we placed the pointer at the beginning itself. So the first fit and the next fit behaved in exact same way. It is not necessary that for next fit we will always start from the last point. It is possible that we start from the beginning of the memory block itself. At that time both will give the same sized hole itself. So this, because of this always over here, the statement becomes incorrect. Next, the hole created by worst fit is always larger than the hole created by first fit. Now in the third example we saw both of them created the same sized hole. Why so? Because the largest hole was visited first. It was placed at the very beginning. So here first fit and worst fit behave within the same way, and hence the size of the hole created is also same. So this always larger is incorrect. It is generally larger but not always larger. Then the third, hole created by best fit is never larger than the hole created by first fit. So now we know that for the best fit, the size of the hole is always the same. It does not change in any situation. But for first fit it can change. But even if it changes, it can never go below the best fit. As you can see here, the minimum is 40, 10, 60. Minimum is 10. So this can never go below the size of the best fit, which means the best fit will always create the smallest possible hole. So the third statement is true. Now coming to the last, hole created by next fit is never larger than the hole created by best fit. Now here we will consider next fit to be the same as first fit. So as you can see in the cases 1 and 3, it is larger than that created by best fit. So this is also incorrect. So the only true statement that we have here is C, the third option.